Hello, my name is Carina Liebers, and on behalf of my co-authors, I welcome you to the presentation of our paper, VisCoMET, Visually Analyzing Team Collaboration in Medical Emergency Trainings. The triage process is a critical part of rescuers' work, where they need to quickly assess the medical condition of casualties and categorize them into 5 priority classes: black, blue, red, yellow, and green. This process is essential to prioritize treatment and transport to the hospital. To achieve this, health professionals must collaborate effectively. To practice the triage process for incidents, field trainings are conducted. However, so far there are no means to identify why a team performed good or bad. We collaborated with social interaction researchers that examine professional team collaboration in a semi-structured work process to understand how team members interact and collaborate. In case of the triage process, they are particularly interested in how the interaction can impact the triage's outcome. Collaborative behavior consists of multiple aspects, like what team members said, where they looked, and with whom they interacted. Aspects of such collaborative behavior are first annotated and transcribed from videos of the triage training. Our scenario involves multiple triage training sessions conducted at a single location, with teams consisting of a leading doctor and a note-taking person. One scenario involved 13 patients located in several vehicles. It was recorded using 4 cameras. Further, eye gaze data was collected of one or both team members. The provided annotations are grouped in channels, also known as tiers. For the triage scenario, there are a total of 13 tiers. To analyze this data, the social interaction researchers lack an overview that can facilitate the comparison and identification of interaction patterns among different teams. Our work is related to the visualization of multi-stream empirical data. It is also an event sequence visualization, similar to timeline-based representations that reveal interactions between parallel events and aggregate and compare event collections. Previous works used several RAWs for different data streams and colored markers to indicate activity. Such John et al. Visualized annotated movies with information on active characters, their activities and used objects, supporting comparing different movies in juxtaposed timelines. Another example is the following work that analyzed teamwork in nursing training and generated a timeline representation of different sessions using networks to visualize communication among the nurses and patients. Clinical Path also uses multiple RAWs to display an overview of patient test results. However, we are not aware of any approaches that visually analyze annotated social interactions across comparable sessions. We identified 3 classes of requirements for VisCoMET. It should cover visualizing individual sessions by including the video, annotations, and triage decisions in contrast to their ground truth. It should enable comparing the information within and across sessions by allowing comparison of parallel events and similar temporal event patterns, and convey an overview of team activities. Further, it should provide specific support for the analysis workflow by allowing for lookup of annotations in the video, documentation of findings, as well as definition and highlighting of interaction patterns between team members. Our timeline-based detail view displays all tiers as group RAWs, with a general group at the top and one group for each team member. The horizontal axis represents time. Annotations are encoded as rectangles, their widths indicating their duration. The importance of these annotations is color-coded from gray to black, specified by the collaborating social researchers. Additionally, triage categories and decisions are displayed in their respective triage colors: black, blue, red, yellow, and green, accompanied by icons and labels indicating their type. The timeline view allows for comparing similar cases among different sessions. When hovering over an annotation, details are revealed in a tooltip. A selection highlights a specific annotation type throughout all displayed sessions, while its video jumps to the start of annotation. Using the alignment feature, users can align the first occurrence of the same annotation type in the sessions with a vertical line. Arrows allow jumping to previous occurrences. The timeline view further allows searching for frequent event patterns in the data by flattening the parallel events into a linear sequence based on 4 types of pattern classes and applying the spam algorithm. In the view's left panel, users can steer the search. The found events are highlighted in blue in the timelines and listed at the bottom of the panel. Their frequency is shown in a stacked bar chart. The graph-based overview shows each training session as a node and the similarities between them as edges. Each node consists of a nested glyph visualization, including team member and overall team behavior by encoding speech events in the team members, gaze events per patient, and parallel activities and arcs on different rings. This creates a visual fingerprint of each session to enable the identification of different team behaviors between sessions. It is used to select sessions for detailed inspection in the timeline visualization. Hovering over the visualization displays more details in a tooltip. By selecting an edge, details on the similarity between sessions are opened. Tables on the left side of the view display all encoded values of the selected training nodes. To evaluate our approach, we first performed a joint analysis of the dataset. Following, I will give an overview of a subset of our insights using VisCoMET. Examining patients. By investigating the examination of patients in the graph overview, we could find 2 anomalies in the data. First, we found 2 cases where there was no gaze event at any patient, which we explained as potential gaze recording issues. Also, we found 3 sessions where the note-taking person looked at patients more often than the leading doctor. This may indicate that the note-taking person had trouble following verbal instructions and needed to assess the patients themselves. Team roles. We use the graph overview to identify a dissimilar session based on the team roles. Here we assume doctors to have more speech events than note-taking persons. Searching for differing sessions, we could identify a training where the note-taking person spoke more. Further, the triage insecurity ratio of this session differed from the optimum of equal decisions per patient cases. The diverting speech events could suggest that the team was either highly collaborative in sharing roles or was experiencing conflicting roles. Reclassification of patients. We observed multiple cases of reclassifications using the timeline view. Next to the reoccurring decision activity, we identified frequent speech events after visiting the patient. This suggests that the team might have had a more in-depth discussion about the case. Following, we want to highlight some of our results. For all findings, please refer to our paper. Regarding the timeline view, visualization experts found it to be successful in displaying annotations and enabling detailed analysis of team interactions. However, while they found that the color coding of triage colors aids comparison, the gray color scale for encoding annotation type importance received mixed feedback. Furthermore, some experts had difficulties interacting with the thin rectangles representing short events and suggested clearer highlighting of events by enlarging corresponding rectangles. Additionally, the pattern panel was found to be difficult to understand. According to the social interaction researchers, the timeline view was easy to understand, particularly in terms of time and event types. They appreciated the comparative features, which allowed to quickly perceive acceleration of the triage process and when a triage was well done. Regarding the graph overview, visualization experts appreciated the design of session nodes, which represent the behavior of teams, and the subnodes encoding the behavior of each team member. They also liked the encoding of attributes as segments, as it aids comparing team members. However, the experts found it necessary to use tooltips to estimate similarity between sessions. Furthermore, they found the dense information encoding in a node unintuitive and difficult to remember. In more detail, they had difficulties remembering the rings encoding, as the node includes different number of rings for the overall team performance and each member. Social interaction researchers first found the graph overview challenging to understand, but quickly adapted after receiving an explanation. They noted that while it effectively displays characteristics and could support evaluations, it requires an understanding of the training sessions. They appreciated its ability to compare sessions and identify interesting aspects. Also, they found it useful for identifying patterns and characteristics in the dataset they could not have identified as easily with a previous workflow. Next, we want to discuss some of our findings. For further discussion points, please refer to our paper. Learning curve. Although visualization experts first raised concerns about the difficulty of the graph overview, social interaction experts quickly familiarized themselves and correctly interpreted the visualization. Hence, the learning curve of the graph overview is moderate. We explain this finding such that the glyphs act as a visual fingerprint, allowing fast recognition of similarities and differences. One major challenge in interactive pattern recommendation is defining concrete constraints for meaningful event sequences. Displaying all existing patterns can lead to a multitude of sequences not all represent meaningful social interactions. To address this, the approach could benefit from interactive navigation of the discovered patterns, such as through a node link visualization as shown in CoreFlow. Also, while automatic pattern search is useful, it only finds a defined set of patterns. Extending the approach to include user-defined ratings of patterns could narrow the pattern set. This way, pattern recommendations could be made based on the user ratings of their meaningfulness. VisCoMET focuses on visualizing already annotated videos, as the collaborating social interaction researchers have an established annotation process. However, it may be beneficial to extend the scope to support multiple levels of annotations. For example, a rough annotation pass could generate hypotheses and identify relevant research questions. Afterwards, an analysis aiming to answer the identified research question requires more fine-grained annotations of the identified aspects of social interaction. To facilitate this, it is necessary to visually distinguish these levels of annotation and ideally support the adaptation and refinement of annotations within the system. This might result in better visualization support throughout different phases of social interaction research. So, to conclude my talk, let us quickly sum up. We introduced VisCoMET, a visual analytics approach displaying interactions of healthcare personnel in triage training to support social interaction research. The timeline view allows to easily relate parallel events in one or between sessions, for example by aligning similar events in juxtaposed timelines. The graph-based overview enables to quickly find similar and dissimilar sessions. By visualizing one session in glyphs as nodes, it displays its characteristics and serves as visual fingerprint. In our evaluation, we found that VisCoMET efficiently visualizes collaborative behaviors and anomalies of team performance in triage scenarios. Social interaction researchers suggest using the system to revise annotations, identify case collections of similar interaction cases, and providing visualization and comparison system in collaborative data analysis sessions. Thank you for listening to my talk, and please do not hesitate to contact me if you have any further questions. Thank you very much.